Hello. Let me start with a short introduction. I'm Frank Kleinert, the man in the middle. Mike here on the right side. Dominic is also there. And we split our presentation in 3 parts. I will speak a little bit about our company, very short. And after this, I will speak about the challenge what we had. And Mike and Dominic speak about the solution. Let me start. A short introduction. That is our company. We have no connectivity to IT companies or some other things. We are really a producer of plastic film, not more. We have IT guys in our company, but the most people in our company, we have around 6,000 people, are production guys, and we produce a film, not more. We produce film for pharmaceutical application, for labels, also the most credit cards what you have in your pocket, based on our film. Around 30% of the credit card business in the world is produced from us. We produce also trays, trays for meat or trays for food and so on. That is our business. We produce in 30 production sites around the world. We produce this kind of film. Here a short introduction, what was our challenge. And you see here on the left side a film, and we produce a film around 2 meters width. The thickness is around between 10 micron and 1000 micron. Your hair is around 50 micron. That means our thinnest film is 5 times thinner as your hair. But we produce also film from 1000 micron. Here on the left side you see 3 different reels produced, and you see here on the left side a quality issue. And that was a challenge. The colleagues from production came to me and said, Frank, we produced the whole weekend, and we found after the weekend the quality control found this issue. How we can detect this earlier, how we can reduce our internal scrap rate, what is possible here. In our production we have this system here in the middle. That is an inline thickness measurement system. And the inline thickness measurement system we use this for our operators to optimize the right thickness in the production, to optimize the profile. And that is a system what we use in our quality control. We measure in the end of the film, and sometimes we produce 20 kilometers film, and after the 20 kilometer, we measure in the quality lab what is a real thickness. That means the challenge was to detect this issue earlier. And here, a short example what we did here. We used the data from the inline measurement system, and you see we produce a film 1695 millimeters width, means nearly this, and 40 centimeters from the left corner, we see this small peak here. And you see the peak is 2 micron. 2 micron, it's, I said before, your hair, the thickness of your hair is 50 micron. That means the thickness increase is very small. You can see this with your eyes, but if in the thickness measurement system with a hand, you see nothing. What we find here, we said, okay, if we use the inline measurement system and we can visualize, we can show the operator very fast this peak, that can be the solution. And we analyzed around 300 cases in our production and analyzed what is the sickness profile, and we found a lot of complaints or credit notes are linked to the sickness profile. You can create a lot of statistics. You can say, okay, we create a box plot, we create a bell curve and the standard deviation or some other things. Or you can use a QQ plot to analyze what is really happened. But believe me, this kind of statistic is not helpful for the operators. The operator, if you say to the operator, your standard deviation is too big, it's not really helpful. What we did with the support from Syntax here is this. And that is our live visualization, what we have now on 28 lines in the Word. That means we started as a proof of concept in Montabaur and roll out this step by step to 2 sites in US, 1 site in Crumlin and also 1 site in Bavaria. And we use this as fast visualization for the operators in our production. And they can see directly, is everything green? Fine. You must do nothing. If something red, you must do actions to reduce the issue. And that is a visualization what we started in this year. Mike.
Yeah, thank you, Frank. So overall, as Frank mentioned, there was a technical issue related to the production area. So we had systems in place with measures, and what are now the effective opportunities we use to get it corrected. So what you can see here is really a standard. So many of those medium-sized companies like KP, within the last 60 years, we are specialized in producing high-class film. But we are not the IT experts, as you heard. We are great guys in maintaining what we have, but we're not the guys developing stuff. But that's work for Syntax, AWS, and other companies. So the situation we see here is we are not fast, which means what we buy is in there. We keep it up a long time running. It was a CapEx. We have no live data. In some sensors, we have live data, but not in every one of those. We have data in silos, pretty common. You have an MES system, you have your quality control system, you have all the different sensors. So you spread the data you have in your organization all around all the environment. You have restrictions related to protocols, to access, to compatibility, all of this. And you have no prediction. That's also something, you just have what you have, but you not share the information with other systems. So that's a really big issue. And as you could see, we were working on how can we transfer what we have today. So on the left side, you see the traditional, I would say, but a standard pyramid you see in every organization which is manufacturing. So you have sensors, PLCs, MES. You have all the variety of systems. And our idea was to harmonize that data, use the data for all the things you want to do, like monitoring, alerting, measuring. So our aim here was really to have a simple solution which is easy repeatedly in other sites. Because as you heard, we have 30 production sites around the globe. So we wanted really to have an approach where we can use like a template and have one setup for every plant and always use the same approach, the same technology to have the costs low and implement it and have it inside the cloud. So as Frank mentioned, by today, I think we have here now 27 production line mentioned. It's 28 by today. And we started really with a POC, so from small to big. And our approach was always have a simple use case, a really quick visualization and a quick ROI to convince and show the value of a solution. It was pretty clear for us if we would start with a project with a 24-month timeline, it's difficult to show the ROI, to show the value. You need something like a small bang, where the organization sees, whoa, all the efforts you had, they really make an impact on the whole organization, on production. So that was really where we started with the POC. The POC went into a pilot, and while we had the pilot, the organization was at least convinced that what we had as a theory model, as a POC, is really value adding to the organization. And that's where the journey starts with the rollout and where we are today. What we want to do is really to ensure that we have an iterative process ongoing. It's not like everything is just in the scope defined in the beginning and we just push through the scope. It's really, as I said, we are not an IT development company. It's really what we see as, oh, you could do this option or you could do it different. We really try to follow an agile approach and have an opportunity to develop the final product still while we are ongoing. And that's what you see. Here, as an example for quality, we have really an approach which is always the same. It's about visualization right back in the MES system. So we're not trying to build a parallel MES system here. For us, it's really the interoperability between the different solutions. And the smart thing here is we are not depending on any MES system. So if the company would decide today, oh, let's see, there was a nice vendor at the HMI, let's pick another MES, it wouldn't matter because we have all those solutions in finding out the root cause and alerting the operator. It's so generic that we would be able to just put it in another MES. Then we define specifications. For sure, you need to have all the upper, lower control limits, when to alert, when outside of whatever limit for the operator. Then you have the alerting, auto-blocking, another opportunity. You saw those 3 reels with the small ring outside. We need to ensure that those reels are not shipped to the customers. There was one thing which Frank hadn't on the one slide. Usually there is an ISO norm where you have the specification limits, what is allowed to manufacture. And those 2 microns, they were full in the norm. So in theory, we could say, hey, everything was fine. We ship it to the customer, and I guess not everybody here is specialist in film production, but you could see the ring. The customer also sees the ring. So it's bad for an organization just to come up, yeah, we are in the limits. No, we want to ensure that when we identify an issue, that it's not shipped to the customers. We don't want to have those discussions about quality. We want to deliver close to 100% of quality to our customers. So that's really something we use the data for analysis. And what you see here as the iterative approach is something we also use now for all the future topics we cover. The solutions we have in place is based on a modular system. So we see like the thickness measurement is one module, but we want to provide also quality control, sustainability or predictive maintenance, but always with the same approach. Always visualization, writing back in the MES or reading in the MES, always follow the specification approach, that it's always the same iterative approach for all the different modules we are creating. And that's something where we are currently working on with Syntax, and I'm happy to share the stage with Dominik.
Thank you, Mike. So, my name is Dominik Schäfer from Syntax, and let me show you today how we enabled and helped Klöckner Pentaplast to achieve what you saw a second before. So, first of all, a couple of words about Syntax. We are a global company, and we have a broad spectrum of services that we serve our customers, starting from hosting over to public cloud services. Very manufacturing focus that we have. And since 5 years, we are also focused on the IoT business and working very closely with AWS there. The solution that we used to help Klöckner Pentaplast to have a short time to market and to achieve their goals is called Synsites. And Synsites is a software as a service solution that we take care on our side, on the Syntax side for Klöckner Pentaplast. It's a 60 to 80% ready-to-use solution. This is the reason why we were able to achieve the short time to market that Frank and Mike were talking about. And our idea is that because everyone is different, every customer has different requirements and challenges, it is possible to really tailor the solution to the customer requirements to 100%. This is the overall idea of Synsites. We serve different use cases with Synsites, but the core use case is the shop floor use case that we have, and within this shop floor use case, we have asset management, predictive maintenance, predictive quality components that we can enable for our customers. Also energy management and threshold-based alerting components that we can enable that help you with anomaly detection and things like that. The solution is built upon AWS and integrated into different other enterprise systems, such as SAP, Oracle, or other MES systems, custom MES systems that we have. Yeah. So this is the under-the-hood view, how Synsites looks. This is usually not something that a customer will see, and I will not bore you with any details about the small logos and what they are actually doing. But overall, the idea is that we can connect any industrial equipment on a shop floor site to our solution with our so-called Syntax Edge connector that we have, having different technologies embedded in there. Data goes into our solution and is handled on this side here in our Syntax data handler, and then orchestrated within our solution. So we have a data space that stores basically all the data that you ingest there. This can be business data, this can be process data, this can be machine data into the data space. And from the data space, we can then integrate with other services, such as predictive services for predictive maintenance, for predictive quality, and things like that. But also with our so-called rules engine, where the main part is implemented that Frank was talking about. So the statistical process control component that actually analyzes the live data coming in and is then reacting on the things and sending out alerts to the other systems, as you saw. Okay, and with that, I hand over back to Mike.
Thank you. Yeah, just giving a quick outlook, what's on the roadmap, what we want to do next. So as you can see, predictive maintenance for sure is something we're really interested in. We all know that the times of having the lines up and running, they are money time, they are value adding. So we really want to be alerted whenever we see something going out of the norm, higher energy consumption, higher temperature, all of those things. We want to have control about sustainability. Not only speaking about the CO2 footprint, it's really about all. It's about our wastewater, everything. So we want to integrate this and have it later on available. Predictive maintenance and quality, for sure it's the same more or less. We will accomplish this in one module. Then the parameter recommended, that's something we already saw some nice example here with Gen AI technology. It is about giving the operator a best value set, that he sees if you are in those specification limits, you would produce the best material, nearly 100% quality. That's what we are aiming for. And then for sure, as you see, it's named automatic production line. That's far in the future. That's something where we really, if we have all the information, if we combine the information, if we make the right conclusions out of this, we would be able to have the machine operatorless, lights out factory. That would be something really in the future. But that's what we're aiming for. So as a conclusion, for us, it's always pretty important to have a POC where everybody can agree on. It's not too cryptical. People need to understand what do you want to accomplish with the solution you want to bring up to fix their issue. You need to communicate the success story. That's also pretty important. It doesn't benefit you if you have a great product, but you are not doing advertisements in your own organization. Because usually the C-level is not interested what you are doing, they're only interested in the results. But you need those guys as a multiplier for your ideas, for your solutions, to ensure that they get on the road and you have more speed in the implementation. The important thing for the focus is really to have a pilot where you really work together with the guys from operations. A nice example is Frank is from Business Excellence, I am from IT. We are not the right guys to tell the operation guys how to run the machines. If we would come up, we have the solution for your problem, that would already be the end of the discussion. So it's important to build up partnerships, to really understand what's the challenge for those guys. What are the issues they have day by day, not what we think they have day by day. So that's absolutely important. And for sure, real-time quality control is pretty important. Frank had the issue, they reported, we had an issue in manufacturing. He calculated backwards. That's not how we should work. We need to know when it happened in real time. And then something which is one of our most favorite topics, what we like to bring up, we want to build a digital twin. The digital twin, it's more like a digital shadow or fingerprint. We are not aiming for the digital twin for the production line, from raw material to the film. We want to focus on the film, on the roll, on the tray at the end, which gives us the opportunity to provide a supplier for machines, as an example, a manufacturer of machines, with the information that he knows. On your roll of 17 kilometers of film, you have, by 1,100 meter, you have a thickness issue, or you have a black spot. We want to provide a digital fingerprint, a digital shadow of every single roll of film we manufacture on demand. And that's all of our presentation. Thanks for your audience, and if there are any questions, feel free.